Hi everyone. In this video we're going to discuss a process called the prime factor test. The prime factor test is a process for determining whether a number is prime or composite. Recall that a prime number is a positive whole number that has exactly two factors, 1 and the number itself. A composite number is a positive whole number that has more than two factors. So for example, 15 is composite because 1 and 15 are factors of 15, but so are 3 and 5. So it has more than two distinct factors. For the prime factor test, it's very helpful to know the rules of divisibility. It's not entirely necessary, but this makes the process go faster. Here is a poster that's actually can be purchased from teacher supply stores. So you could purchase this and actually post it in your room. And this reminds students of some of the rules of divisibility. The rules of divisibility from 2 to 10. So for example, the rule for 3, if the sum of the digits is divisible by 3, then the number is divisible by 3. Again, these rules are not absolutely necessary, but make the prime factor test go a little bit quicker. The other helpful tool is another item we've already discussed in class called the Sieve of Eratosthenes. And the sieve just identifies prime numbers from 1. And remember, 1 is neither prime nor composite, it's just 1. Up to a given number, in this case for this sieve, 100 or 100. So the process again for the sieve, start with the first prime, which is 2. Cancel out all the multiples of 2, go to the next prime, the next, and so forth, canceling out all the multiples. At the end, what you're left with is you're left with two sets of numbers. The numbers that were not crossed out, in this case are green, are the prime numbers, and the numbers that are crossed out are the composite numbers. So this is a very helpful tool for identifying all of the prime numbers up to a given number. Now, let's use the prime factor test. The first question and the first number we want to investigate or examine is 441. In general, the question is the same for each of these. Is this number prime or composite? This is a number that I wouldn't need to essentially fully use the prime factor test, because looking at the number and knowing your divisibility rule, you might say, again, 4 plus 4 plus 1, the sum of the digits is 9. 9 is divisible by 3. What that says is that 3 is a factor of 441, or 3 divides 441. Since 3 is a factor of 441, 441 is a composite number. The next number we'd like to consider is 689. 689 is a number that, off the top of my head, I don't know if it's prime or composite. Again, that's what divisibility rules do. I know that, for example, that this number is not even, so it's not divisible by 2. If I add up the numbers, 6 plus 8 plus 9, that equals 23. 23 is not divisible by 3, it's not divisible by 9, so 3 and 9 are not factors of 689, but there might be others that I just don't know off the top of my head, and there are other divisibility rules that I don't necessarily know. So there's no quick divisibility rule for 689, so we're going to use the prime factor test. The prime factor test, the first step of that is taking the square root of the number, and that's the square root of 689 is 26.24. So the prime factor test says that we need to check all of the prime numbers, all the prime factors up to 26.24, and determine whether each one is a factor of 689. And that's all we need to check. Why don't we need to go bigger than 26? Well, the square root is sort of like halfway in terms of all the factors of 689. If you have a factor that's greater than 26, its partner, its pair, is going to be less than 26. So we only need to check prime factors up to 26.24. From the sieve of Eratosthenes, you would find all of those factors. And from the sieve, all of the prime factors that are less than 26, and I've got a list right here. So what is there? 9 of them. So we need to check 9 factors to determine whether each one is a factor of 689. I've already done a couple of them. I've already ruled out 2. I've already ruled out 3. 9 is not a prime, so I don't need to check that. 5 does not go into 689 evenly because the last digit's not a 0 or 5. Off the top of my head, I don't know the divisibility rule for 7, and I don't know one for 19. So what I recommend you do is either long division or just bring up your calculator. So for example, 11. Is 11 a factor of 689? Take 689, divide by 11, and that equals 62.63. In other words, 11 does not go into 689 evenly. So 11 is not a factor of 689. We could rule that one out. Let's try the next one, 13 on our list. 689 divided by 13 equals 53. Okay. So 53 does go into 689 evenly. What does that say? That says that 689, there we go, 689 equals 13 times 53. So 13 is a factor of 689. It's not 1, it's not 689. That says that 689 is a composite number. The last number to check is 1103. 1103, okay, so that is, again, are there quick divisibility rules for 1103? Off the top of my head, I don't know them. I know, for example, that that number is not divisible by 2. I know that 1103 is not divisible by 3 because 1 plus 1 plus 3 equals 5, and that's not a factor, it's not divisible by 3. So again, we don't have is not one that's obviously a factor of 1103, so we use the prime factor test. Take the square root of 1103, that is 33.21. So the prime factor test says check all the prime factors, P, which are less than 33.21. From the sieve of Eratosthenes, I've got a list of them right here. I can already rule out a few of them. I know 2 is not divisible. I know 3 is not divisible. I know 5 does not go into 1103 because the last digit's not a 0 or 5. For the others, again, use long division or just your calculator. Let's check 29, for example. 1103 divided by 29, and that equals 34.03. It almost works, but not quite. It does not go into 1103 evenly. When you check every number on this list, none of these numbers divide 1103 evenly. So that says that 1103 is prime.